Okay, so now that we know about ions from the previous video, let's talk a little bit about ionic bonds and naming them. All ionic bonds are going to be made of a cation and an anion. Cation first, anion second. Remember, your cations are always positive and your anions are always negative. So what we're going to need to do is find, for a binary compound, which is made of two elements, we'll need to find one cation and one anion. So before we get into what your compound is going to look like in the end when these two things combine, we're going to talk about how we name these compounds. The cations, your metals, your positive charged ions, keep the same name. Nothing changes. On this table, our cation here is Ca, which stands for calcium. And your cation always goes first because it's positive. Now, when you're talking about ionic bonding, your anion is always going to be second. And your anion name does change from the periodic table name. What will happen is the ending will be changed to IDE, pronounced "ide." So in this situation where we have Cl, which is usually chlorine, chlorine as an ion is chloride. So the name of this compound is calcium chloride. Here we have barium, which is our cation, which is positive, combining with oxygen, which will become oxide. So the name will be barium oxide. This is how you name binary ionic compounds. Binary meaning two-element compounds. So now that we know how to name them, how do we know what subscripts go on the bottom? Well, write the ions as they are on this periodic table, which you received in class. And basically, any cation can combine with any anion on the sheet, including the polyatomic ions up here. So let's just do an easy one. Let's do sodium chloride, salt. Na, find it on your table, has a charge of +1. And chloride, over here on your periodic table, has a charge of -1. Atoms in group 1 and group 17 love to bond together because atoms in group 1, ions in group 1, have an extra electron they want to get rid of to get full, and atoms in group 17 need an extra electron to be full, so they can get together and both meet each other's needs. So how do we go from having these superscripts up here to having these subscripts on the bottom? Well, what we do is we look at the numbers on top and we get rid of the signs and we swap and drop. So you're going to have Na1, Cl1, and we do not need to write the ones there in this instance because this is a lot like algebra. You don't have to put 1x, you can just put x. So eventually this compound would just be calcium chloride, NaCl. Let's do a couple more. Okay, let's do an element from group 2 this time. Let's do beryllium. Be has a +2 charge. And then let's go ahead and combine it with nitride, which is your nitrogen ion, with a -3 charge. So what you're going to do is you're going to get rid of the signs. We don't need those. Then we're going to do what we like to call swap and drop. You take the element symbol, the superscript up here, and you're going to swap the numbers up top and drop them down below. So the number that went with nitrogen or nitride before was 3, that number is going to go to beryllium now. And I'm going to drop it down. And the number that was with beryllium, which was 2, is going to now belong to my nitride. So when these two combine, they will form beryllium nitride, which is Be3N2. Now for a lot of your binary compounds, you're going to take an element that I've highlighted in blue, and you're going to combine it with an element that I've highlighted in red or black to make a simple binary compound. So far we always know the charges of the elements depending on what group they're in. Group 1 has a +1 charge, group 2 has a +2 charge, group 13 has a +3 charge, 14 can be plus or -4, 15 is -3, 16 is -2, and 17 is -1, and 18 has no charge. Now all these elements in the middle are our transition metals. They're all metals, so they're all going to have a positive charge, so they're all cations, but we don't know what charge they're always going to have. It can change. And how do I know what charge they have? Well, I'm going to show you. If you know your Roman numerals, you'll always know what charge your transition metals have. Okay, just because your transition metals have different charges than you expect every time doesn't mean that they're hard. You're still going to do the exact same swap and drop. So say you've been given the formula chromium Roman numeral 3 oxide. That Roman numeral 3 is letting me know that chromium will have a +3 charge. So when I'm doing my formula, I'm going to write Cr +3. And then oxide, if I check my table, I can look at it. Oxide is in group 16, so I know that it has a -2 charge. And now I'm going to do my little swap and drop. 2 is going to go here. My 3 is going to go here. We get rid of these signs. So my final formula for chromium 3 oxide will be Cr2O3. Okay, let's do another one. Lead 2 chloride. I'm going to look for my formula. What's my chemical symbol for lead? It's Pb. And I'm told right here that I'm going to have a +2 charge. Pb +2. Chloride doesn't change charges. So all I have to do is look. I can see that it's in group 17. So it's going to have a -1 charge. Just going to swap and drop. Get rid of my signs. And put my numbers where they belong now. So my final answer will be Pb1, which you can write or you can leave off, Cl2. And since you don't have to write the 1, let's go ahead and just take it off of there. PbCl2 is the formula for lead 2 chloride. So what if I'm given an ionic compound with the transition metal, like iron here, but I'm not given the name? How do I find the name? Well, you're just basically going to reverse what you did before. So we know that when we are given a name of a compound, we're going to write it out. We're going to put the charges as superscripts, and we're going to swap and drop them. So if I reverse this, I know that up here is where the 3 is going to go, and above the O is where the 2 is going to go. So my formula would have looked like this before: Fe3 +3 O -2. So I know that if I were to write the name of this compound, it would be iron 3 oxide. You just do the opposite, and that's how you can take a compound and get the name out of it. So now you might be saying, okay, I can do binary ionic compounds with either transition metals or elements that continue to have the same charge. But what about when we're doing ternary compounds, which means three, which means more than one element? It's not always 3 though, sometimes it's more. This is when we got into our polyatomic ions. And if you look back at your ion periodic table, those are those little elements that combine together to create a single charge. They are up there in the top box. And they act the same way any other element does. They just have more than one element in them. So just look at this graphic here. We're going to do the same thing. Here you've got zinc with a +2 charge, and phosphate, which I know the name of from my periodic table chart, with a -3 charge. I'm just going to get rid of those charges. I'm going to swap and drop, which is going to leave me here with zinc phosphate, because the 3 from the phosphate went down here and the 2 from the zinc went down here. Notice how PO4 is in parentheses. This is very important because you don't want to accidentally put your subscript down here instead of a 4 or only on the O. You need to make sure that you keep all your polyatomic ions together in parentheses when you're doing it. So let's practice a couple of these. So here we have potassium, which has a +1 charge because it's in group 1. And we have chromate, which has a -2 charge. So we're going to do the same thing we've done every single time so far. We are going to get rid of the signs, and we're going to swap and drop. So get rid of that. Your 1 goes down here. Your 2 goes down here. So you're going to have potassium with a 2 subscript in parentheses CrO4. And you do not need to bring the 1 down because we are understood that there is a 1 there if you wrote out the entire polyatomic ion. So this would be what you would write for potassium chromate. Okay, now that we have learned the 3 different kinds of ionic compounds, I think that you guys should be able to practice this. So I've given you 3. If you want to pause the video and see if you can write them correctly from their names, I'll give you the answers here in just a second. Okay, here are the answers. Calcium has a +2 charge and sulfide has a -2 charge. So when I swap and drop, I'll have 2 on each side, which I can reduce to 1, giving me a final answer of CAS. Iron here has a +2 charge and nitride always has a -3 charge. So when I swap and drop these, I'm going to get Fe3N2. For potassium chromate, I had to use my polyatomic ion chart. Potassium has a +1 charge and chromate has a -2 charge. So when I swap and drop, I'm going to write K2 and then I do not have to write the 1. It's invisible. It's understood under my CrO4, giving me potassium chromate. I hope that this explains how you can write formulas for ionic compounds. Good luck.